how are you all? I hope you all are fine. Okay students, have you all completed your homework? I hope you did your homework. Okay, last class we have learnt about basic algebraic operations of complex number like addition, multiplication, subtraction and equality of complex numbers. Today we are going to learn about properties of complex numbers. Okay, so properties of complex numbers and addition and multiplication are same as real numbers. See, consider two real numbers, 2, 3 belongs to all. Now if you add these two numbers, we will get again a real number. This also belongs to all, isn't it? 2, 3 belongs to all means 2 plus 3 equal to 5. This also belongs to real numbers. So, now we are going to learn about properties of complex numbers under addition and multiplication. Okay. Now, always these complex numbers satisfy the following properties. Okay. Now, first property, closure property under addition. For any two complex numbers z1 and z2. For closure property, we need two complex numbers. Let us take z1 and z2. If we add these two complex numbers z1 and z2, if we add means the sum z1 plus z2 is also a complex number. What is the closure property? If we take two complex numbers z1 and z2, z1 plus z2 is also a complex number. Let us consider an example. z1 equal to 1 plus I and z2 equal to 3 plus 4I. See, this is one complex number, this is another complex number. Now we are going to add these two complex numbers, z1, z2. See, 1 plus I plus 3 plus 4I. See, in earlier classes you have learnt how to add two complex numbers now. How to add two complex numbers? Yes, we have to add real numbers and we have to add corresponding imaginary numbers. Now 1 plus 3, 4 plus I plus 4I, 5I. See, this is also in the standard form x plus iy. This is also a complex number. So when we add two complex numbers, again we get a complex number. So this is called a closure property. Okay. See, under multiplication, the closure property under multiplication is take two complex numbers z1 and z2. The product z1 into z2 is also a complex number. See, let us consider the same example. 1 plus I and 3 plus 4I. See, multiply these two, z1 z2, 1 plus I into 3 plus 4I. Now earlier classes you have learned, isn't it? Just it's ordinary multiplication. So multiply 1 with 3 and 4I. 1 into 3, 3 plus 1 into 4I, 4I, I into 3, 3I plus I into I squared into 4. So 4I squared, already you know the value of I squared, minus 1. So minus 4. Okay. Now add this. 3 minus 4 minus 1. 4I plus 3I, 7I. See, look at this. This is also in the form of x plus iy, isn't it? So we get a complex number. So when we multiply two complex numbers, again we get a complex number. So this is called a closure property. So what is closure property under addition? z1 z2 complex number means z1 plus z2 also a complex number. Same way z1 and z2 under multiplication, the product z1 z2 also a complex number. Next, commutative property. Commutative property is z1 plus z2. For any two complex numbers z1 and z2, it satisfies z1 plus z2 is equal to z2 plus z1. Always the sum of these is equal to sum of z2 plus z1. See, here if we add z1 and z2, we will get 4 plus 5I, no? Now z2 plus z1, first we will write z2 complex number 3 plus 4I. Next, z1 complex number 1 plus I. Now what will you get? 3 plus 1, 4, 4I plus I, 5I. So always this should be equal. So z1 plus z2 also 4 plus 5I and z2 plus z1 also 4 plus 5I. So this is commutative property under addition. So similarly, commutative property under multiplication is z1 into z2 is equal to z2 into z1. Okay, so this is called a commutative property under addition. This is under multiplication. See, addition means insert plus sign between two complex number. Multiplication means insert multiplication symbol between two complex number. It's always Z1 and Z2 equal to Z2 into Z1. Then associative property. See, for associative property we need three complex numbers. For any three complex numbers, Z1, Z2 and Z3. See, Z1, Z2, Z3, three complex number. Now we are associating these two, Z1 and Z2 plus Z3. This always equal to Z1 plus Z2 plus Z3. Z2 plus Z3. Okay. See, this is associative property under addition. See, multiplication. What will you do? Insert multiplication symbol now. So now associate these two. Z1, Z2 and Z3 is equal to Z1 into Z2 into Z3. So always these values equal to this one. So this is associative property. See, next, additive identity. In real number, 0 is the additive identity and 1 is the multiplicative identity. Generally, in real number, 0 is called additive identity and 1 is called the multiplicative identity, isn't it? Now, I'll ask one question. S2 is a complex number? S2 is a complex number? If you said S means, what is the reason? If you said no means, what is the reason? Okay, let me explain. See, when we take simply 2, so this is real number. While this 2 can be written as 2 plus I0. 2 plus I0. 0 and anything 0. 0 plus anything same number, isn't it? So now look at this. This is in the form of 2 plus I0. 2 plus I0 like x plus Iy. So this is the standard form of complex number, no? So when 2 can be written as in the form of 2 plus I0 means this is a complex number. Okay. So generally simply 2 means it is a real number. But if we write 2 plus I0 means it becomes a complex number. Got it? Okay. Now I told 0 is the additive identity, no? Now while in complex number this 0 can be written as 0 plus I0. So because it is a complex number, no? So it must be 0 plus I0. So 0 is the additive identity of the complex number and it satisfies 0 plus Z is equal to Z plus 0 equal to Z. So if we add with one complex number 0 plus 1 plus I means obviously what is this? 1 plus I. This is nothing but if you take this as say Z means is equal to Z. So this is the concept. Now 0 plus Z equal to Z plus 0 equal to Z. Generally if you add 0 with any number means you get the same number. So similarly complex number also like that. Okay. Next the multiplicative identity. 1 is the multiplicative identity. Okay. Now this can be written as 1 plus I0 because it is the complex number. And it satisfies 1 into Z is equal to Z into 1 equal to Z. So while multiplying complex number with 1, we get the same complex number. So this is called the multiplicative identity property. Okay. Then next, additive inverse. Generally in real number, consider 5. What is the negative of 5? Minus 5. See, negative of 5 is minus 5. 5 belongs to R and minus 5 also belongs to R. So this is a real number. Okay. Now we are going to find additive inverse of a complex number. See, for every complex number Z, there exists a complex number minus Z. Okay, for every complex number Z, there exists some complex number minus Z such that it should be satisfies the condition Z plus that inverse minus Z equal to minus Z plus Z is equal to 0. Okay, so what is 0? It's nothing but additive identity. Okay, 0 plus I0. So when we add one complex number and its inverse, we get identity. Okay, so this is the concept. For every complex number Z and there exists a complex number minus Z such that Z plus minus Z equal to minus Z plus Z equal to 0. So what is the conclusion? Minus z is called the additive inverse of z. Or inverse of z is minus z. Simply just you put minus symbol in front of z. So what is the inverse of z? Additive inverse of z minus z. So this is the concept you should know very careful. Okay. Inverse of z is minus z, or minus z is called the additive inverse of z. Next, multiplicative inverse. Real number. Consider real number. Now 6 belongs to real number. What is the reciprocal of 6? 1 by 6. This is also belongs to R. So, if you take 6 belongs to R, then the inverse 1 by 6 also belongs to R. Now, if we multiply these two, number and its inverse, what will we get? 1. What is this? This 1 is nothing but multiplicative identity. So this is generally in real numbers. Now we are going to see in complex number. For any non-zero, this is very important. Non-zero complex number is z. Why we are taking non-zero complex number? So if we take 0 means 1 by 0 infinity. We cannot define, we cannot find. So that's why this is the condition they have given, non-zero complex number. But in addition, it's no problem. Whatever the complex number, it is acceptable. But multiplicative inverse, that complex number, it must have non-zero complex number. That means it should not be equal to 0. Any non-zero complex number. Okay. So for any non-zero complex number z, there exists a complex number w and it satisfies z into w is equal to w into z equal to 1. Now w is equal to 1 by z, or if we take to the numerator, it becomes z power minus 1 is called the multiplicative inverse of z. So what is the multiplicative inverse of z? 1 by z. Okay, 1 by z is the multiplicative inverse. We may use this concept into two more questions. Additive inverse of z is minus z. Multiplicative inverse of z is 1 by z. Okay. Now distributive property. Distributive property, that is multiplication distributes over addition. Okay. Now the property is z1 into z2 plus z3 is equal to, now just you multiply these two, z1 into z2, put plus symbol, then you multiply this, z1 into z3. See, this is the z1 into z2 plus z3 is equal to z1 into z2 plus z1 z3, no? So for any three complex number, always these two should be equal. Now take another one. See, first two complex numbers, associate these two, z1 plus z2 into z3. Now you multiply these two, z1 into z3 plus z2 into z3. So these are the basic properties of complex numbers. See, you should understand this concept and you memorize this formula. Okay, don't separate addition, multiplication. Just you memorize what is associative property under addition, what is associative property under multiplication. Similarly, you have to memorize this concept thoroughly. Why I am telling this means, sometimes they may ask in 2 mark question, 3 mark question. How means they will give some complex number z1 and z2. Okay, using that concept, prove that these complex number with under associative property, or under prove that this is commutative, like that. So if you know the concept means, easily you can attempt that question. That's why I am telling, just you memorize all this concept. Okay, shall we move to exercise problem? Okay. So last class we have completed 2.2. Now we are going to see 2.3 exercise. Second problem. If z1 equal to 3 and z2 equal to minus 7i, z3 equal to 5 plus 4i. Three complex numbers are given. And show that z1 into z2 plus z3 is equal to z1, z2 plus z1 into z3. And second question is z1 plus z2 into z3 is equal to z1 into z3 plus Z2 into Z3. Do you remember what property is this? It's nothing but distributive property. Multiplication distributes over addition, isn't it? So this is distributive property, Z1 into Z2. So here three complex number given. They are telling to show these two are equal. Okay, let me explain how to prove this. See, first two problems given. I have taken second problem. So first one is homework. Okay, students. Okay, what is second problem? Z1 plus Z2 into Z3 is always equal to this one. We are going to show this. Okay. Oh, before that, first you take LHS side. What is in LHS? Z1 plus Z2 into Z3. So first we have to find the bracket term. What is in the bracket? Z1 plus Z2. So take Z1 plus Z2. Now what is Z1? 3. You write 3 here. Next put plus symbol. And what is Z2? Minus 7i. Plus into minus, minus 7i. So Z1 plus Z2 equal to 3 minus 7i. Next, now we found bracket term now. Next you find Z1 plus Z2 into Z3. Now you write Z1 plus Z2. 3 minus 7i into Z3. 5 plus 4i. This is nothing but what? Product of two complex number. You know how to find the product of two complex number because in last exercise we have learnt, isn't it? Okay. Now we'll multiply this one. First 3 multiply with this 2. 3 into 5, 15. Plus into plus, 3 4s are 12i. Next you multiply this. Minus into plus, minus 7 5s are 35i. Next you multiply this. Minus into plus, minus 7 4s are 28. I into I squared. Now the value of I squared is minus 1. Minus into minus, plus. So directly I put plus symbol here because obviously last class we have learned, that's why. So 28. Now this is addition. Addition, just you add real numbers and add imaginary numbers. 15 plus 28, 43 and plus 12i minus 35. So these are the different symbol. Put the greatest number sign and you subtract this. 35 minus 12, 23i. So LHS is 43 minus 23i. Consider this as equation 1. Now take RHS. What is in the RHS? Z1 into Z3 plus Z2 into Z3. Here two terms are given. Okay. First you find first term. Then you find second term. Then add these two. Okay. So first term. Z1 into Z3. What is Z1? 3. What is Z3? 5 plus 4i. So just you multiply. This is the number. So easily you can multiply. 3 into 5, 15 plus 3 4s are 12i. So this is first term we found. Then second term Z2 into Z3. What is Z2? Minus 7i. What is Z3? 5 plus 4i. So this is also very easy. Minus into plus, minus. 7 5s are 35, you put I. Minus into plus, minus. 7 4s are 28. I into I squared. The value of I squared is minus 1. Minus into minus plus. Therefore, plus 28. So, second term also we found. What is the next step? We had to add first term and second term. What is first term? 15 plus 2i. What is the second term? Minus 35i plus 28. So this is nothing but addition, ordinary addition. So just we add real number. 15 plus 28, 43. And 12i minus 35i minus 23i. Consider this as equation number 2. So look at the equation 1 and 2. From 1 and 2, Z1 plus Z2 into Z3 is always equal to Z1 into Z3 plus Z2 into Z3. These two are equal, hence shown. Okay students, this kind of problem is very easy because already we know the answer. So if you attempt this question means easily you can get full mark. So you select such kind of questions during the examination time. See, once again we call the question. 3 complex numbers are given. They are telling to show this concept. Now whenever we have to prove or show, first we have to evaluate bracket term. So take bracket term first. and simplify. After that you multiply this to LHS side, we will get this, consider this as 1, and next RHS side, RHS side 2 terms are given. First term product of two complex numbers, second term also product of two complex number. Just you multiply and add, we will get the same answer, hence shown. Now exercise 2.3, three problems given. These two are homework. What we have done in the first one, similarly this also. Now third question, three complex numbers given. Find the additive and multiplicative inverse of Z1 and Z2 and Z3. So I do one problem. So remaining Z2, Z3, just you do it as a homework. First Z1 equal to 2 plus 5y. Previous, just now we have learnt now, additive inverse of Z is minus Z. Here Z1, they have given 2 plus 5y. So additive inverse of Z is minus Z. Here Z1, that's why minus Z1. It's nothing, just we are going to multiply with this minus 1. Okay. So minus into 2 plus 5y. So multiply this minus into plus, minus 2, minus into plus, minus 5y. So additive inverse of Z1 is minus 2 minus 5y. Next multiplicative inverse. What is the formula? Multiplicative inverse of Z is 1 by Z. Here they have given Z1. So multiplicative inverse of Z1 is 1 by Z1. So 1 by Z1 is 2 plus 5y. See here, you should be very careful in this. See, when fraction form is given, division form is given, 1 by 2 plus 5, this is not in the standard form. We can't write this as 1 by 2 plus 1 by 5, that is wrong. See, 1 by 2 plus 5i, when fraction form is given means, this is the concept, always you should multiply the denominator. See, look at the denominator, 2 plus 5i, we should multiply the conjugate of the denominator, both numerator and denominator. See, next class we will learn conjugate. Okay, now conjugate is nothing but, see, 2 plus 5y. Look at the imaginary part. Imaginary part plus means you change into negative, minus 2 minus 5y. Suppose if it is minus means conjugate of 2 minus 5y is 2 plus 5y. That's all. Check. Now I will ask one question. 2i minus 5. What is the conjugate of this one? Anyone? Suppose if you said 2i plus 5 means it is wrong. Why it is wrong? What I told, whenever if you want to find conjugate means you have to see the imaginary part. Suppose if it is plus means you change it minus. Suppose if it is minus means you change it as plus. No need to worry about the real part. Just you look at the imaginary part. Now here imaginary part is 2, no? So you change this minus 2i minus 5. This is the conjugate. Or you write this as minus 5 plus 2i, because generally the complex number form x plus iy, no? So you write it as, and then afterwards you find conjugate. Got it? Okay. Now 1 by 2 plus 5. This is in the standard form, x plus iy. So no problem. Just conjugate. Plus 5, no? Put minus. So multiplying numerator and denominator by 2 minus 5i. So 1 into 2 minus 5i, 2 minus 5i. See, look at this. 2 plus 5i into 2 minus 5i. This is in the form of a plus b into a minus b. Algebraic formula. Do you remember? A plus b into a minus b is nothing but a plus b into a minus b is a squared minus b squared, or a squared minus b squared equal to a plus b into a minus b. See, this is also like, but this is real numbers, but this is complex numbers, no? And complex number comes means a plus b into a minus b form becomes a squared plus b squared. Why miss? In complex number this becomes a square plus b square. I will explain. See, here I know I into I square. I squared value minus 1. So if we multiply minus into minus, it becomes plus. That's why whenever complex number, while multiplying complex numbers, suppose if the form is a plus b into a minus b means just you write a square plus b square. Okay, in that time don't put I because b is 5i, so obviously the answer is a square plus b square. See, just here I am explaining detailing a square 2 minus 5i square. See, 5 square 25, I square value minus 1, so minus into minus plus 4 plus 25. 2 minus 5i by 29. You may think this is also a fraction form. How it will treat as a complex number? Okay, see the denominator having just a real number. We can decompose it into two terms like 2 by 29 plus I into minus 5 by 29. This is also a real number now. What is the concept? X plus iy is the standard form of a complex number and x and y are real numbers. See, this is a complex number but x and y are real numbers. Now 2 by 29 also real number, no? Minus 5 by 29 also real number. So, inverse of, multiplicative inverse of z1 is 1 by z1. This is also a complex number. But we can't write 1 by 2 plus 5i is 1 by 2 plus 1 by 5. This is wrong. Already previously I explained that. Because this is a denominator complex number. Suppose if it is real number means we can write, but the numerator it should be sum of two numbers. In that time itself we can decompose it. Okay. So now this is a complex number. Therefore multiplicative inverse of z1 is 1 by z1. That's all. Okay children. Remaining you do same. Okay. I hope you all will do this homework and you write it in your note. Thank you.